Hi, in this video I'm going to go over the questions for the exam review to give you an idea about some of these questions and to help you prepare better for the exam. So here we go. Question number 1, I give you a set of data and I want you to compute the following statistics. The first thing you do is I would like you to create a sheet and name it Q1 because you're going to submit your data anyways. I would highly recommend that you put your data in one column. It's just easier to work with. That's best practice on Excel. My data is in column here. I just cut it and pasted it. The next step, I computed all of my statistics using the data analysis tool. Let me do that one more time for you. Go to the data tab, data analysis tool, and then descriptive statistics is selected. Click OK. For the data range, you're going to select your data. So I'm just going to click on the letter A, and then I don't have labels. This is in columns. The output range, I want it to appear in this cell. So I'm just going to select an empty cell here. And then I have to check summary statistics and click OK. So that is the data that I have. It computed everything for me. All I need to do now is to just double check for the mode because I can have multiple modes. To do that, I'm going to select multiple cells and then type in = mode.bolt and then select my data again. I'm going to click on A and then click enter. I used to hold the control key and click enter, but for my new computer, I didn't need to do that. So just click enter right away. And that is going to give you multiple modes if there is a chance that you have multiple modes. But in this case, I have one mode, so this is accurate. If you have multiple modes, enter them in the answer box as numbers separated by commas. The next step is to find the quartiles. The question is asking about the quartiles, so the next question is to find the quartiles. You can do that using box and whiskers, but keep in mind to change the setting for the box and whiskers to inclusive of the median, because if you don't do that, chances are you're going to make a mistake. An easier way to do it is to compute them individually. It's not hard. So you're going to say quartile inclusive and then click on that, comma 1 for the first quartile, and you want the third quartile. Make sure you're labeling because I will be reviewing your answers and comparing your answer to what you should have done. Quartile inclusive again, and then select your data, comma 3 for the third quartile, enter. So this is the third quartile, Q3. Now I need the interquartile range. The interquartile range is Q3 minus Q1. So this is IQR, and then you want to find the upper fence and the lower fence. The upper fence is equal to Q3 plus 1.5 times IQR, and the lower fence is equal to Q1 minus 1.5 times IQR. Click enter. So this is the upper fence and lower fence, and this is how you compute it. The last question is asking about the shape of the data or the distribution. The shape of the data, you can find it in two different ways. Those are the easiest ways that I'm going to show you. The first way, which is the easiest way, is to compare the mean and median. You have the mean already and you have the median already. What you can do here, you can say, okay, if the mean is bigger than the median, this is a number line. Let's assume this is 0 and this is infinity. So those numbers go from small to big. So if the median is going to be in the middle and the mean is bigger than that, mu, then the shape is going to be, the bulk of the data is going to be here around the median. And then the tail is going to be towards the mean. The mean always tends to go towards the tail of the data. It follows the outliers of the data. So if that is the case, if the mean is bigger than the median, then in this case, you will have skewed to the right data. If it's the other way around, if the mean is less than the median is going to always have the chunk of the data and the mean is going to have the tail of the data. So as you can see, the tail is towards the mean here. That means we have a skew to the left data. If they are approximately the same, then the data is going to be approximately normal or bell-shaped or approximately symmetrical. That is the first idea. The second idea is to use box and whiskers. So I'm going to select my data, go to the Insert tab, go to the Histogram and select box and whiskers. The reason why we select box and whiskers is because we want to determine whether we have a right tail or a left tail. As you can see, the top whisker is bigger. That means the tail is to the right. Basically what I do I usually flip this in this direction. So I have the box here, and I have the bigger whisker here and the smaller whisker here. If I draw my data, the chunk of the data is going to be in or around the box, and then the whisker is going to be a tail. So as you can see here, this is right skewed distribution, or it is skewed to the right distribution or shape. So this is the first question. The second question, this is a matter of interpreting and being able to read the box and whiskers. So when you have a box and whiskers shape, usually we have it vertical on Excel, but it's the same if it's not vertical. Let me show you the vertical shape and then the horizontal shape and compare them together. Okay, so the horizontal shape is just flipping this or putting this down. The first line, which is the end of the first whisker, is going to be the minimum. The first line of the box is Q1, or the first quartile. This is the second quartile, or the median. And this is the third quartile, and that is the maximum. If you have an outlier here, then this is the minimum. If you have an outlier here, then the outlier is going to be the maximum. So same here, we start from left to right. This is the minimum, and this is Q1, this is Q2, and this is Q3, and this is maximum. All of these numbers, we read them from left to right, and we sometimes separate them with commas, and we call them the 5-number summary. The next question is asking if the pie chart is an appropriate graph for qualitative data. The answer is right. The reason is because the data that we use the pie chart to display is usually not numbers, it is proportions. The best way to come up with something to display a quantitative data is to compute the proportion. Let's say I'm asking a group of students whether they prefer an online class or a synchronous class. So I will have, do you prefer an online class? And I will get the answers yes or no. And I'm going to count the numbers of students who say yes and divide that by the total number of students. That will give me the proportion of students who said yes. To represent that, a good option that I have is to display that on a pie chart. It just looks nice. You can do that on a bar graph. It's another way, but the pie chart is mainly used for displaying qualitative data results. In a study, the data you collect is the number of traffic tickets. Is that quantitative or qualitative? We said that quantitative data means it's a number that you can add, subtract. It has a quantity attached to it. A qualitative data, it could be a number, it could be responses other than numbers, and they don't have any value attached to them. For example, if I ask you, what grade level are you in? If you say, I'm a 5th grader, number 5 is a number, but it's not quantitative because it doesn't mean anything other than your rank in education. So that is qualitative. Another example for quantitative data is the number of traffic tickets. So I could have 0 traffic tickets or 1 traffic ticket or 2 traffic tickets. Maybe I accumulated 20 traffic tickets. No one knows. So those numbers, they have quantity. So if I say 20, you're going to be shocked. If I say 2, okay, 3, okay. So you see that I express some quantity that it makes sense to you. So this is for sure a quantitative kind of data. Determine whether the value of a parameter is statistic. So we said the parameter is basically a number that is computed from the population, or it is a number value that is computed from the population. And then the statistic is a number that is computed from a sample. So reading this right away, it says a sample of men revealed 60% took calculus. I am looking at a sample here, so this is definitely going to be a statistic. It's not going to be a parameter. Is this value from a discrete or continuous data? We said the discrete variable, basically in simple terms, is anything that you can't cut into fractions. You can't break it down into fractions. For example, the number of phones you own. You can't have one phone and a half. The number of kids you have. The number of pets you have in the house. So all of these are discrete numbers. You can't cut them in half. While the continuous data, you can have fractions in it. For example, the number of dates you eat per day, and I mean the dates, the fruits, not the people. You can have 5.5 dates. It's possible, right? If you look at this is just the height in centimeters. So the height in centimeters can be centimeters and few millimeters with it. So it does come with fractions sometimes. So this is definitely a continuous type of data that you're going to get out of this. A political scientist surveys 37 of the current 110 representatives in the state's legislature. We want to determine the sample size and the population size. So if a state has 110 representatives in the state's legislature, then that is the population. You can't have more in that specific state. If you survey a part of them, which are 37 of them, then that is the sample size. So hopefully that made sense. Question 8. Does this describe an observational study or an experiment? The growth rate of bacteria is compared before and after adding alcohol. Since you are adding something into the study and testing, that means this is an experiment. Observational studies happen when you don't interfere with your population or the individuals in the population and in any way. So you don't control anything, you don't give them anything, you don't change any conditions that your individuals are in. In this case, we added alcohol to the population of bacteria and we compared the growth after and before adding alcohol, which is basically an experiment. We want to identify the type of observational study. The college will collect data by surveying you yearly for the next 10 years. So this type of observational study is going to be prospective. That means it extends to the future. If it was retrospective, that means it's reviewing information from the past. And it's definitely not cross-sectional because it doesn't ask you the question on the spot at a point in time. So it is going to extend to the future. That makes it a prospective. In a study, the data you collect is favorite candy bar. So look at the answers here. Always when you determine the type of data you collect in, you look at what is the outcome of this experiment or the question that I'm asking. So if the question collects your favorite bar, the answer is usually going to be maybe Twix or maybe Snickers or Mars, any other bar. So in this case, you see my answers are just brand names, which makes this one qualitative data. In a study, the data you collect is miles driven between last oil change. What type of data is this? Of course, the miles you put on your car between oil changes is a number that is quantitative. It quantifies something. So this is definitely a quantitative data, and it's going to be continuous data. The state education department requires local schools, districts to keep these records on all students' age, race, ethnicity, days absent, current grade level, standardized test scores in reading and math, and any disabilities or special education needs the students may have. Which of the following data is categorical data or qualitative data? So out of these, disability or special needs is definitely one of the categorical data because it's not a number. Race or ethnicity is also, the answer to that is going to be different from one person to another, but it definitely is not a number. So it's also qualitative data. Current grade level, it is a number, but again, this is a labeling number. It's not a quantitative number that you actually measure the quantity with. The student name, in this case, the student name is not even a type of data that you can collect because the outcome is going to be different. It's going to be Jason, Aisha, Mustafa, maybe Tien, different names. So as you can see here, the outcome is, yes, it's a name, but it's not even like a variable that we can do anything with. For example, if I asked you, do you have any special needs or special disabilities, then the answer is going to be yes or no. I can then measure the ratio of people who need special accommodations to the people who don't need special accommodations. I can measure something. But if I have your name, what am I going to do with that? It's just, just know your name. So it's not even a data that can be recognized as qualitative data or quantitative data. Reading test scores is going to be a number. Mathematical test score is a number. So those are quantitative, not qualitative. Days absent is going to be quantitative. The age is also quantitative. So we're going to go with these numbers only. Let's look at question number 13. Question number 13 says, the treatment, what is the definition of the treatment? Let's look. So the treatment is anything that we subject our individuals in the study sample to, which is also known as the experimental conditions imposed on a subject, that is Option C. The retrospective study. Retrospective study, we said it collects information from the past. So this is a study in which data is collected from the past or examined from the past, which is option B. Experiment. The experiment is a study in which a treatment is applied and responses are observed. So we have to give our individuals in the survey a treatment and then measure the response of the individuals in the survey. So this is what the experiment is, which is option D. Observational study is a study in which data is collected without anything being done to the subjects. So that is option E. And then lastly, experimental units are the people or the animals or the things that we are experimenting with. So those are what we call experimental units, which is option A, or we call them individuals also. So that is how you answer that question. 14, determine whether the value is a parameter or statistic. 20% of vehicles sold are compact cars. So this is talking about all cars. So I'm going to say this is a parameter. In a sample of students who passed statistics, 70% use statistics in their future careers. So it's a statistic here because we're studying just a sample of the students. Portland Community College determined that 89% of the students who took Math 251 successfully completed the course. It's a parameter because it's just talking about all of the students who took the this specific course. Medical researchers measured the height of 125 males and found that their mean height is 69.5. So they took a sample, which makes it a statistic. In a study, the sample is chosen by selecting a room of the house and appraising all items in that room. This is the method we use for cluster sampling. We take the entire population and then divide it into groups, and then we take entire groups for study. This is the cluster method that we use for sampling. In a study, a sample is chosen by asking our 40 closest friends. This is a convenience method because it's just convenience to ask our friends. So this is a convenience method for sampling, and it's not the best method out there. In a study, the sample is chosen by surveying every third driver coming through a toll booth. So this is what we call the systematic sampling, which is choosing every eighth person out of the population. In a study, the sample is chosen by surveying people in your next class. This is going to be a convenience sampling, because it's just very convenient to survey the next class people. You can find them easily, and they're not random people. You know those people. Question 19, match the name of the sampling method to the description given. Divide the population by age. Select 5 people from each age. This is stratified sampling, and this is part 8. This is option A. Dividing by population by voting precinct and sampling everyone in the precinct selected. This is cluster because you are taking everybody. So this is B, cluster. Pulling 50 names from a hat. That is a simple random sampling. This is E, option E. Choosing every fifth person is systematic, so it's option D. Asking people on the street. Asking people on the street is convenience, so it's going to be C. Examine the following survey question for any sources of bias. Given humanity's great tradition of exploration, do you favor continued funding for space flights? This is a bias question because it gives you a hint to what a favorite answer is or what you should answer, or at least it's going to give you a motive to answer yes. So this is definitely a biased question. If we just leave this out, it's going to be a better one. So yes, this is a source of bias. It's going to create a response bias because if you probably didn't see that part, you wouldn't choose yes. You would choose no or maybe or any other response. So this is basically a biased question. So if you want to construct a better question, you might say, do you favor continued funding for the space program? That would be less biased because it just doesn't encourage you to say yes. Sampling technique scenarios. Let's match these scenarios with with the sampling technique that is used. You want to investigate the voters' opinion on an upcoming issue for your city. You obtain a list of all registered voters and randomly select 100 names. You contact each of the randomly chosen voters and ask for their opinion. This is simple random sample. You work for a company as a quality control specialist. You want to check the current production of products for defects. At the end of the day, you assign a number to each item that was produced. You randomly choose 20 numbers and inspect the items that correspond to the randomly chosen numbers. That is going to be simple random sampling. You work for the school newspaper. You want to survey the students for their opinion about the recent issue. During the hours you have assigned to work on a newspaper, you walk around the school interviewing students that are available. This is convenient. You work for a company as a quality control specialist. You want to check the current production of products for defects. You locate the finished products for the day and inspect the first 20 items you happen to see. This is convenience. If you want to investigate the voters' opinion on an upcoming issue for your city, the city that you live in has 12 different neighborhoods. You randomly select 10 registered voters from each neighborhood and contact them to ask for their opinion. This is a stratified method. Does the following describe an observational study or an experiment? Subjects are shown a video of children and puppies playing happily together, and the subjects' blood pressure readings are recorded immediately afterwards. So because the subjects are influenced by that video, for sure, this is going to be an experiment because you introduce something new to your group. So this is not an observational study. 2 sections of statistics are taught by the same teacher. One section uses my stat lab, the other section does not. At the end of the semester, grades in the 2 sections are compared. It's going to be an experimental study. So this is not an observational study. So this is an experimental study. Let me try another word. Experiment. It's an experiment study. Let's see if it's going to take it. Okay. Determine the type of sampling bias. A local hardware store wants to know if its customers are satisfied with the customer service they receive. The store posts an interviewer at the front of the store to ask the first 135 shoppers who leave the store, how satisfied on a scale of 1 to 10 were you with this store's customer service? This is basically a sampling bias. It's going to produce sampling bias because you're just conveniently selecting the first 135 shoppers. An online newspaper conducted a survey by asking, do you support the lowered and fair quality standards if it could cause the death of millions of innocent people from pollution-related diseases? So this question is going to produce a response bias because it is influencing your response by suggesting that if you say yes, then you are contributing to the death of millions of people, which is no one would like. A college wants to survey students about reducing the hours for computer lab. To conduct a survey, they select the next 50 students to enter the lab. This is going to produce a sampling bias because, of course, those 50 students are going to need the lab, and this is just a convenient method of sampling, which is not a good way of sampling. For this question, we need to find the class width. So the class width, to find it, you're going to subtract 2 consecutive numbers. So 2 consecutive numbers vertically are like 210 and then 200. So if you say 210 minus 200, that's going to give you 10, which is the class width. And similar, if you say 229 minus 219, those are 2 consecutive numbers vertically. So that is also going to give you the class width. For this type of question, we want to find the relative frequency. So to find the relative frequency, you're going to take your data. Let me just copy this into an Excel sheet, and you're going to paste it here. The first step is to find the sum of the data, the frequencies. Because the relative frequency is basically each frequency divided by the sum of frequencies. So I'm going to click on the first frequency. I'm going to divide it by 50. Which happens to be the sum of my frequencies, and then I'm going to populate. I want to find everything, and then I want to turn these into percentages because the question is asking you to report it as a percentage. So I'm going to click on Home, click on the Numbers section, and select this option. The class that I was asked about is this class right here. So the relative frequency for this class is 12%, and that's why I have it here as 12%. For this type of question, Number 27, this is an important question because it's very systematic and you can actually answer this question quite easily. I'm going to take the data, I'm going to paste it here. The first step is we want to find the minimum because that's just what the question is asking. So minimum, compute the minimum of the data, and we need the minimum later on. So my minimum is this number. I'm going to label it, and then the question is asking to find, take the minimum and divide it by the class width, and it gave me the class width to be 200. So I'm going to go ahead and do that. So this is equal to the minimum divided by 200. And then it's asking me to round this number down. So to round it down, just remove any decimal points. So it's going to be 9. Now the next part is, which the part that we mostly struggle with is, if you do the minimum divided by the class width and then round it down, then the last part is going to be easy. The first lower class limit is going to be basically you take the number you rounded, which is 9 in my case, and multiply it with the class width, which is 200 in this specific question. So you take this number that you just rounded and you multiply it with the class width. This is the lower class limit of the first class. So this is how you answer this type of question. So we get 9.05, and then the minimum was 1810, and there we go. So that is how you answer that question. You're presented with the histogram and you want to find the sample size. To find the sample size, you're going to say, you're going to add all of the frequencies up. So you're going to say the first frequency is 4, and then the second frequency is 2. So you're going to say 4 plus 2 is 6. And then this is 7. No, it's 9. Sorry. So plus 9, 15 plus 14, 29, 29 plus 10, 39, 39 plus 2, 41, 41 plus 2, 43. 43 here. That is how you find the sample size. You're going to determine the shape of the distribution by looking at the histogram. As you can see, there's a big chunk to the left and a small tail going to the right. In this case, because the tail is moving to the right, or it is on the right of the shape, I'm going to say this is skewed to the right distribution. You have numbers here and you want to create the stem and leaf diagram. Basically, you're going to look at your data and you have the 10th place ready for you. So all you need to do is to fill in all of the leaves. I don't have any 20s here, so I'm going to leave the first box open without any numbers because I don't have any 20s. In the 30s, I'm going to begin with 33. A good idea is to go ahead actually and take this data and paste it into an Excel, turn it into columns, and then here. So I'm going to just turn this into one column so it's easier for me to work with. And it's not going to take a long time. Once you get that done, it's going to save you a lot of time and trouble. The reason I do that is because I want to keep everything ordered from smallest to greatest, and I can do that only if I have it in one column. So now I'm going to select my data, go to the data tab and sort my data from smallest to greatest using this function right here. Oh, I have 25. You see, I almost missed that one. So for the first column, I have 5 only, and then you go to the next one, I have 3, 8, 9. So I'm going to say here 3, 8, 9. And then let me double check to make sure. Okay. And then I have 002 for 4, 002. Don't forget the zeros. Zeros are numbers. 002. And then for 5, I have 1, 2, 3, 5, 5, 5, 8, 9. 1, 2, 3, 5, 5, 5, 8, 9. And 6, I don't have anything. So that is how you're going to build the stem and leaf diagram. From this question, you're going to read the box and whiskers and you're just going to plug the numbers that you see. So the minimum here is 0. The first quartile is 2, sorry. The second quartile or the median is 10 and the third quartile is 12. The maximum is 13. The interquartile range is Q3 minus Q1, which is 10. The range is the maximum minus the minimum, which is 13. Which quarter has the smallest spread of data? So I see here that the maximum quarter has the smallest spread of data. Each of these is quarter of the data. So this is quarter, this is a quarter, this is a quarter, and this is a quarter. And that's why we call them quartiles. So I see that the fourth quartile, which is the maximum one, the fourth quartile has the smallest spread of data because it's the shortest one. Which quarter has the largest spread of data? That is the second quartile, or the second quarter. As you can see here, the distance from 2 to 10 is big there. The amount of data between the values 2 and 12. So between 2 and 12, this is 2 quarters, which makes up 50% of the data. 2 quarters is 25% plus 25%, which is 50%. The amount of the data between 12 and 13. So between 12 and 13, this is 1 quarter. Between the third quartile and the maximum, this is 1 quarter, which is 25% of the data. So that is 25% of the data. So this is how you answer this type of question. To answer this question, you want to determine whether the shape is skewed to the left or skewed to the right or symmetrical. We said that the shape is skewed to the right if the mean is bigger than the median, because the mean is going to be in the tail, and the tail will be to the right because it's the big. It is the big number. So the first one is going to be option C. And then if the mean is less than the median, that means the mean is going to follow the tail. So the tail is to the left because the mean is smaller. So that is option A, which is a left skewed distribution. If the mean is equal to the median is equal to the mode, then we have a symmetrical distribution. Or if they are approximately the same, then we have the same distribution. This set of data is easy to figure out, so I'm not going to answer that question. For this type of question, the rounding suggested in the book is to round to 1 more decimal place than the data that you have. So I have like 1 decimal place here. That means I'm going to round to 2 decimals. If you have two decimals here, you're going to round your numbers to 3 decimals. So you're going to add 1 extra decimal each time. And you're going to use Excel in this case. You're not going to use any other softwares that you see here. This is not a hard question to answer. This is a sample, so you're going to compute the sample standard deviation, not the population standard deviation. This is an empirical rule question. The first thing you do, you're going to create the empirical rule with all of the numbers on it. I have the mean 63 and the standard deviation is 9. So let me show you how you're going to create that. Here is my shape, which is a bell shape. I know that the mean is exactly in the middle. So the mean in this question is 63 and the standard deviation is 9. So I have 63 here and I want to find 3 numbers to the right. 1, 2, 3, and I want to find 3 numbers to the left. 1, 2, 3. You're going to add 1 standard deviation at a time. So the easiest way to do that is I usually put the number 63 here. And then I say this is equal to 63 plus 9. And then I go to the formula that I just created and drag it 2 more times. So that will give me the rest of the numbers. Similar here, I'm going to say this number minus the standard deviation. And then I'm going to take the number here and I will go and drag it 2 times. So that will give me the numbers to the right. So this is 72 and this is 81 and this is 90. Make sure you have enough space. 54. And 45 and 36. And then you're going to put the numbers at the top, which are 34%, all of these are percentages, 13.5, 13.5, 2.35, 2.35, and don't forget the tail 0.15, 0.15. Now you can answer these questions easily. It says here 99.7% of the widget weights lie between what 2 numbers? We know that from the empirical rule that 99.70% lie within 3 standard deviations of the mean. That means 3 standard deviations of the mean is basically we go from the mean 1, 2, 3. So between this number and 1, 2, 3 and that number. So between 39 and 90. So I'm going to go here and I will say between 39, not 36, 39 and 90 is the 99.7% of the widget weights. What percentage of widget weights lie within or between 54 and 90? So I'm going to go to my shape again and I will determine the numbers given in the question, which is already I forgot, 54 and 90. Okay, so 54 is this number right here. So I'm going to highlight the line. and 90 is this number right here. So I'm going to highlight the lines. So anything between those two lines is going to be the answer. So now I'm going to add all of these percentages to find the total. So 34 plus 34, which is 34, 68 plus 13.5 plus 2.35. So I'm going to add everything here. 34 plus 34 plus 13.5 plus 2.35 is equal to, so the answer here is going to be 83.85. So 83.85 is the answer. What percentage of which lies below 81? Below 81 means anything less than 81. So again, I'm going to highlight the number. I'm going to choose a darker color. The number is 81. I want anything below that. That means anything to the left of it is going to be the answer. Okay. So I have everything highlighted here and I can't see my numbers anymore. So I'm just going to add them up. I know that this section is 13.5 plus 34 plus 34 plus 13.5 again, plus 2.35 plus 0.15. It's very important to add the tail 2, which gives me 97.5. So that is 97.5. So that is how we're going to answer that question. Let me just double check my first answer. So the first number was 36, actually, not 39. So I was right the first time. So this is 36. Typo. All right, now 37. Adult men have heights with a mean of 69 inches with a standard deviation of 2.8 inches. Find the z-score of a man 64.2 inches tall to 2 decimal places. So I kind of mentioned this very quickly in the class, and I said that when you want to compute the z-scores, you go into, we want to standardize 64.2. Okay, let me see, the standard deviation is 2.8. And the number I want to standardize is 64.2. Okay, so I'm going to say here equals standardize. The number is 64.2 and the mean is 69 and the standard deviation is 2.8. So that is the z-score. You're just going to copy that and paste it into your answer box. Paste it here. Okay, so this is how you're going to compute the z-scores that you see. I will do another video to cover the questions 39 through 60 in a different video. I will see you later.